Welcome in this channel Vijay K video or Vijay Prasad 4475. Today's topic is testosterone. In previous lectures, videos, we learned about estrogen, progesterone, and today is testosterone. Testosterone is 19C carbon 19 steroid hormone. We may say it as male hormone. This is now from where it is secreted. Site of secretion. Site of secretion. Mainly secreted from leading cells of testis. Leading cells or interstitial cells of testis. In a small amount, it is secreted from thecal cells of ovaries, and in a small amount it is also secreted from adrenal cortex, that is which they are zona reticularis. We know that this adrenal cortex is divided into three layers from above downwards: zona glomerulosa, then fasciculata, and innermost is zona reticularis. From zona reticularis, some amount of this hormone is secreted. Now coming to steps of secretion. What are the steps? So it is cholesterol. Cholesterol is a basic component, basic substance of synthesis for this testosterone. From from cholesterol, it is pregnenolone. Pregnenolone is formed. After that, 17-hydroxy pregnenolone. Pregnenolone is formed. After that, dehydro AP androsterone. AP androsterone is formed. Dehydro AP androsterone is formed, and from this androstenedione is formed, and finally testosterone is formed. So the steps of secretion in these cells, starting from cholesterol, is the basic substance. Cholesterol, pregnenolone, 17-hydroxypregnenolone, then dehydro AP androstenedione, and finally testosterone is formed. This is the steps of secretion. Now level of testosterone. In adult male, In adult male, it is 300 to 1000 nanogram per deciliter in adult male. Then in adult male, adult females, it is 15 to say 75 nanogram per deciliter. In old age, it decreases. Level in old age, level decreases. Now coming to after secretion, it enters into circulation. In circulation, transport of transport of testosterone. About 60% combines with or banded with this GBG, that is gonado gonadal steroid binding globulin. It is type of globulin, gonadal steroid binding globulin. Then it is almost fixed. It is not dispensable. Fixed testosterone. It is not distant. About 35% with albumin, and only 1 to 2% is in pre-state. 1 to 2% is in pre-state. This is about normal level daily secretion and daily, deciliter. Daily secretion is 4 to daily secretion in male is 4 to 9 milligram per day. Average is 7 milligram per day. In female, it is one below 1. It is below 1 milligram per day. This is normal, and in old age it decreases, and transport of testosterone is by gonadal steroid binding globulin, then albumin, and 1 to 2% in free state. This is now metabolism. It is metabolized in liver. Metabolic in liver. Liver, it is metabolized first into dehydro epiandrosterone, then it conjugates with glucuronic acid and acid to form 17 ketoesteroids. Ketoesteroids, and this is excreted in ketoesteroids, and this is excreted in urine. This is about metabolism. Site of metabolism is destruction is in liver. Mechanism of formation. How it is formed or synthesized. Testosterone is formed from, we learned that from cholesterol to pregnenolone to 17-hydroxypregnenolone, then dehydroepiandrosterone, androstenedione, and finally testosterone. Regulators of regulators of synthesis. Regulators of synthesis. How it is regulated? From hypothalamus. In hypothalamus, preoptic nucleus. Preoptic nucleus. This will release gonadotropin GnRH, that is gonadotropin releasing hormone. This will go to the anterior pituitary. On anterior pituitary gonadotropes. It will act on gonadotropes leading to gonadotropes leading to release of FSH and LH, that is follicular stimulating hormone and luteinizing hormone. This luteinizing hormone will act on target cells and cause formation of cyclic AMP. Cyclic AMP that will cause formation of this hormone, testosterone. Testosterone. When testosterone is formed, it will inhibit negative feedback. It will inhibit formation of GnRH, that is gonadotrophic releasing hormone. It will depress it, and also this LH formation. This is negative feedback mechanism. In this way, it is synthesized, control of synthesis. Now coming to mechanism of action. Mechanism of action. Testosterone is a steroid hormone. It enters into the cells, all cells, but where androgen receptors are present, androgen receptors are present, it will exert its action. Testosterone plus androgen receptor will, it is present in cytoplasm of the cell, and this will enter into cytoplasm, enter into the nucleus. It will enter into the nucleus, where it will cause a stimulation of DNA parts, and this will mRNA, messenger RNA is formed. This will lead to formation of muscle mass and different types of proteins by action on protein kinase A. This is mechanism of action. What are the functions? What are the functions of testosterone? It is responsible for development and maintenance of development and maintenance of secondary sexual character in male. Secondary sexual characters in male. It is responsible for development of internal and external genital organs. External and internal genital organs. Number three, it helps in spermatogenesis. Spermatogenesis responsible for libido. These are the main function of testosterone. Then effect on muscles. Protein synthesis increases. Protein synthesis increase muscle mass, sodium, potassium, water, calcium, and phosphate retention. And phosphate retention. It is powerful stimulant of erythropoiesis by forming erythropoietin, stimulating erythropoietin, powerful stimulant of erythropoiesis. Bone mineralization, and epiphyseal closure. Epiphyseal closure. So these are main functions of testosterone. In this video, we learned about what is testosterone, from where it is secreted, site of synthesis, steps of synthesis, and mechanism of synthesis, regulation of synthesis, mechanism of action. All these things I have covered in this video. I think it will help you, and please like, share my video and follow me. Don't forget to comment. It will help me in improvement of my videos. Thank you very much.